We're in Rosen, Discrete Mathematics and its Applications, section 13.3, talking about finite state automata. We've discussed deterministic finite state automata and non-deterministic finite state automata, DFSAs and NFSAs. And we show here that if we have an NFSA, we can always find a DFSA equivalent to it. That is, one that can recognize the same language as the NFSA. So that if L is recognized by NFSA M0, we can create DFSA M1 that also recognizes that same language. We're going to show this by construction, and we do that step by step so that remembering that in an NFSA, our transition function maps to sets of states. So each state in M1 is going to be labeled with a set of states in M0. So each state in M1, yes. And then the start symbol will be, for M1, will be the set containing S0. Remember, S0 comes from M0. The states in M1 will be labeled with sets of states. They have the same input alphabet. And then this looks like the label of a state in M1. It's a set of states from M0. And then we'll only be taking one symbol at a time. And then it takes this state to the union of the next states in M0 for the elements in that set. So wherever X maps each of these states in M0, we're going to create a state, if it doesn't exist, that has all the union of all those destinations. So here's our transition function from state 1 given X, state 2, I2 given X in M0. That's a set of states in M0. I put them in a set, and then I make that a label of a new state in M1 if necessary. Or it might already exist and I can just map to it. Okay, then we'll just continue that way to construct all the states of M1 from M0, counting for all possible inputs at each state. Remember, we're constructing a DFSA, so its transition function will truly be a function. And then the final states of M1 are those that contain a final state in M0. And we'll see that they are equivalent because if a input string is recognized by M0, that is, one of the states can be reached from state 0. Then M1, this will also lead to a string that contains a state that is a recognition state. And we say that that is also a final state in M1. And conversely, if M0 doesn't recognize a string, it won't lead to any final state in M1. Let's